So this is a question from UNEB 1993, and we're being told to try it out. So we're being told to integrate ln bracket x squared minus 4 dx. Now this one is an example where this property of improper fractions is actually just a step. So this number is actually a long one. It looks simple, but it's actually a very long one. But what we're going to do is we're going to solve it step by step until we understand it properly. So as you can see, this number here requires us to first use integration by parts. So in integration by parts, we're going to assume that there is a 1 multiplying the ln x squared minus 4. So we're going to let u be equal to ln x squared minus 4. Then we're going to let dv dx be equal to 1. As you can see, the best way of solving this is by adding an e to both sides, and we'll have e ln that. And then I'll have eu being equal to x squared minus 4. Then du dx shall be equal to du dx eu shall be equal to 2x, and therefore we can see that du dx shall be equal to 2x over eu. But eu is x squared minus 4, so that means du dx is equal to 2x over x squared minus 4. Now right here, to find the v value, we can see that we just have to integrate the 1, and v shall be equal to x. So now from the formula of integration by parts, this is what we have. So we're going to substitute in the values. So where there is a u, we're going to substitute in our u value, we're going to substitute in our v value, minus integral of, so we're going to substitute in the v value, the du dx value dx, and that's what we have. So now this is what we end up having, but we can actually see that this part here still needs to be integrated even further. So let's look at this integral now here critically. Alright, so let's look at this integral here. So as you can see, the denominator is actually a difference of two squares, but before we even do that, we can already see that the power of the numerator and the power of the denominator are already equal. So this is actually an improper fraction that we're dealing with. So as you can see, the degree of the numerator and denominator are equal, so this is an improper fraction. So by long division, we're going to have to simplify that. So we have 2x squared plus 0x plus 0. So let's just solve for that into x squared minus 4. So we're going to divide it by x squared minus 4. As you can see, 2x squared divided by x squared is 2. So 2 times x squared minus 4 is 2x squared minus 8. So subtract that, and as you can see, we'll have a remainder of positive 8. And why is that? It's because 0 minus negative 8 is like 0 plus 8, which is 8. Then the rest just cancel. So therefore, our mixed fraction shall be equal to 2 plus 8 over x minus 2, x plus 2. Remember that this x squared minus 4 is the difference of two squares, so it can be expressed this way. So we're going to let 8 over x minus 2 over x plus 2 be equal to a over x minus 2 plus b over x plus 2, because now these are actually linear factors. So when you find the LCM shall be x minus 2 into x plus 2. So when you divide this by x minus 2, we have x plus 2 times a. Divide this by x plus 2, we have x minus 2 times b. And then you can say the denominator values cancel, and we're left with 8 being equal to that. So as you can see, the easiest way of solving is now for us to find the value of a. We're going to first let the x be equal to 2. So if x is equal to 2, we can actually see that this is what we end up having. So this actually becomes 0, and then we're left with a, for a being equal to 8, which a shall be equal to 2. Alright, so next we're going to make use of this equation right here again, but now the difference is wherever there was an a, we're going to substitute in a 2. And this is what we end up having. So you can open these brackets, and we'll have 2x plus 4 plus, open these brackets, bx minus 2b. And then we're going to group the terms that actually have an x and the terms that actually don't have an x. So we have 2 plus bx plus 4 minus 2b. And then now we can equate corresponding coefficients on both sides. So we shall actually see that 4 minus 2b shall be equal to 8, of which 2b is equal to negative 4. As you can see, because 4 minus 8 is negative 4, and then b shall be equal to negative 2. So therefore, we have 2 over x minus 2 minus 2 over x plus 2 as that part for the partial fractions. So therefore, our general fraction shall be equal to 2 plus 2 over x minus 2 minus 2 over x plus 2. So now we remember that we're integrating it, so we're going to integrate those partial fractions, because now we need that answer for the integral of 2x squared over x squared minus 4. So when we integrate this, we can actually set, I can actually pull out a 2 can be factorized out of all, and then I can actually see that here definitely the integral of 1 is x. The integral of this, using u substitution, you'll see that it will have ln x minus 2, and then right here the integral of this shall be equal to ln x plus 2, also using u substitution. So multiply these 2 inside the brackets and we'll have 2x plus 2 ln x minus 2 minus 2 ln x plus 2 plus c. So this can also be arranged this way, because a ln minus a ln is like division. So I have this divided by that with a 2 outside, because there is a 2 in common on both of them. Then we can take back to the original integral, because remember that we're dealing with integration by parts at the very beginning. So how will this look? So this is what we'll have. So now we have ln x squared minus 4 being equal to x ln x squared minus 4 minus this. But now remember we found the value for that. So now we have this minus that. So when we open these brackets, we can actually see that we have a minus 2x minus, so this becomes a negative minus 2 ln x minus 2 over ln x plus 2 plus c. So therefore the integral of x squared ln x squared minus 4 dx shall be equal to x ln x squared minus 4 minus 2x minus 2 bracket ln x minus 2 over ln x plus 2 plus c. And that is what they wanted.